Hello friends, welcome to the session Water and Wastewater Treatment Part B. I am Dr. Nandakishore Suryavanshi from Department of Industrial Chemistry, Art Science and Commerce College, Chikaldara. Today we are going to see the secondary and tertiary treatments of water. In secondary treatment, the dissolved and colloidal organic matter remained from primary treatment in wastewater is removed by biological processes involving bacteria and other microorganisms. These processes may be aerobic or anaerobic. Let's first see aerobic treatment. In aerobic process, bacteria and other microorganisms in presence of dissolved oxygen and in proper environmental conditions consume organic matter as food and convert into simpler compounds such as carbon dioxide, water, nitrates and sulfates which are non-pollutants. This is carried out in three steps. First, coagulation and flocculation of colloidal matter. Second, oxidation of dissolved organic matter in carbon dioxide. Third, degradation of nitrogenous organic matter to ammonia. Almost all organic substances, with a few exceptions like hydrocarbons and ethers, can be oxidized by aerobic biological treatment. Thus, secondary treatment reduces BOD. It also removes the appreciable amounts of oils and phenol. However, secondary treatments are expensive. The most commonly used systems for biological wastewater treatments are trickling filters. The trickling filters consist of circular or rectangular beds which are 1 to 3 meter deep and made of broken stones, PVC, coke, synthetic resins of size 40 to 150 millimeter. Over this, wastewater is sprinkled uniformly on entire bed with the help of rotary sprinkler having nozzles. Thus, the wastewater trickles or drips in a small stream through the media. In the filter, there is an arrangement to enter the air at bottom counter current to the effluent flow from the media. A gelatinous film containing bacteria and aerobic microorganisms known as zooglia is formed on the surface of the filter medium which grow on the nutrients supplied by sewage or the wastewater. These organic impurities in wastewater are absorbed on the gelatinous film during its passage and then oxidized by bacteria and microorganisms. When the thickness of the film on the medium increases, a part of it is gets detached and carried away along with the effluent. This effluent from the trickling filter is then allowed to settle in settling tank to retain the sludge particles and then discharged. As we consider trickling filter as an aerobic process, it is indeed not true because the aerobic bacterial species are mostly present in the upper layer of the filter while anaerobic species are at the interfaces of the stones. Smaller media give better results but they easily choke. Synthetic plastic media are found to be very useful for industrial waste of higher quantities. The microbial film formed is very sensitive to temperature that is proportional to the temperature of wastewater passing through the filter. The efficiency of the filter decreases in winter. Trickling filters have greater resistance to toxic wastes. Also, they can remove BOD up to 65 to 85%. The another process used in aerobic treatment is activated sludge process. This is the most versatile biological method used for the treatment of wastewater containing dissolved solids, colloids, and coarse solid organic matter. In this process, the sewage or industrial wastewater is aerated in a reaction tank in which some microbial floc is suspended. The aerobic bacteria make the biological degradation of the organic wastes into carbon dioxide and water while consume some matter for synthesis of bacteria. The bacteria grow and remain in the form of floc which is called as activated sludge. The effluent from the reaction tank is separated from the sludge by settling and then discharged. A part of the sludge is recycled to the same tank to maintain the microbial population for fresh wastewater added. The surplus sludge is digested in sludge digester along with the primary sludge obtained in primary sedimentation. Effective aeration of 3 to 6 hours for sewage and 6 to 24 hours for industrial wastewater is required. About 90 to 95% BOD removal can be achieved by this method. The microbial flocks formed in this process contain zooglial masses of living organisms along with their food and slime material, that is unpleasantly thick and slippery liquid substance, and act as active centers for biological oxidation, and that is why it is called as activated sludge. For this method, at least 0.5 ppm oxygen must be present. Oxygen is provided either by mechanical or by diffused aeration systems. The secondary treatment of wastewater can also be carried out in anaerobic way. Under anaerobic conditions, that is in absence of dissolved oxygen or gaseous oxygen, some microorganisms, for example, hydrolyte and methane forming organisms, convert the complex organic compounds to simple and low molecular weight organic acids and alcohols. These are then covered by methane bacteria to carbon dioxide and methane. Anaerobic treatment can be carried out in depth without the need for the large surface area. It can take place in mixed or enriched cultures and can therefore be maintained in large scale. The process is applicable for most of the substances except that of few like lignin and mineral oils. The process is less expensive but less effective as compared to the aerobic treatment because of dark color, odor, and higher residual BOD. Anaerobic treatment is mainly applicable for digestion of sludge. However, organic liquid waste from dairy, slaughterhouse were treated by this method economically and effectively. The efficiency of this method depends upon pH, temperature, absence of oxygen, and toxic materials. Now let's see tertiary water treatment. Tertiary treatment is the final treatment like polishing the effluents from the secondary treatment processes to improve its further quality. The major objectives of the tertiary treatments are removal of fine suspended solids, removal of bacteria, removal of dissolved inorganic solids, removal of final traces of organic matter if required. Removal of finely divided suspended solids can be achieved with the help of microstrainers and sand filters. Removal of bacteria is carried out by retaining the effluents from secondary biological treatments in the maturation ponds for specified period of time. The final effluent is chlorinated if necessary. Removal of dissolved inorganic solids is major problem with wastewaters from industries such as fertilizers, textile, processing, tanning and electroplating. Any one of the following treatments can be employed. Precipitation method. Chemical precipitation is the most common method for removing dissolved metals or inorganic chemicals from wastewater solution. To convert the dissolved metals into solid particle form, a precipitation reagent is added to the mixture. A chemical reaction by the use of proper precipitating agent causes the dissolved metals to form solid particles. Filtration can then be used to remove the particles from the mixture. How well the process works is dependent upon the kind of metal present, the concentration of the metal, and the kind of reagent used. In hydroxide precipitation, a commonly used chemical precipitation process, calcium or sodium hydroxide is used as the reagent to create solid metal hydroxides. Electrolysis method. In this process, electrochemical reduction of metal ions to elemental metal takes place at cathode. The process is useful for recovery of copper tin, silver, and other metals from electroplating, etching, and pickling baths. The efficiency of this process is found to be greatly increased by applying the new techniques such as EcoCell involving rotating electrodes, particularly suitable for concentrated wastes, and extended surface electrolysis, specially suitable for dilute wastes. Ion exchange method. The use of ion exchange method for demineralization of water is well known. This process is now also used for wastewater treatment for removal and recovery of toxic chemicals. Ion exchange process is economical only when the recovered salts are used in the processes as like in the electroplating industry. Special ion exchangers are available for the removal of toxic metal ions from industrial wastewater. Application of ion exchange for wastewater treatment involves the recovery of chromium, nickel, phosphate, and sulfuric acid from anodizing baths, recovery of copper, lead, and mercury from cooling tower, and removal of cyanides from waste streams. Evaporation method. This method requires energy and hence is an expensive one. It is used only when the recovery of solids or concentrated solutions is important for reuse, for example, as in electroplating wastes. This method is also used when the volume of the wastewater to be treated is less. This method is also useful for concentrating radioactive liquid wastes. It is also the it also allows the recovery of variety of process chemicals. It is applicable to remove or concentrate chemicals which cannot be regained by the any other method. Adsorption method. Adsorption carried out with the help of activated carbon is useful for removal of small quantities of organic matter from wastewater. Special types of adsorbents are available for toxic heavy metal ions from industrial wastewater. Activated carbon treatment is particularly effective for the removal of pesticides like DDT and carbamate insecticides. Adsorption process using activated carbon, peat moss, brown coal, and other cellulose material also finds application in wastewater treatment for the removal of refractory organic toxic metals and colors, etc. The ALM series of adsorbents developed in Japan includes high polymer products containing S and N functional groups. The products have very high attraction for heavy metals and can reduce metal levels in mining and industrial wastewaters to less than 1 ppb.